Hello and welcome back to another episode of Effective JaRu, the series where we read Effective Java, the book, and try to port the items of the individual chapters into idiomatic Rust, if possible. So, in the previous session, we have dealt with basically the fact that in the moment you create any class, you inherit possibly invalid equals implementations and hashcode implementations for your new class here. And because I think I didn't make that clear, in Rust this doesn't happen at all. In Rust, by default, your struct can do nothing. You don't have any implementation of any of the traits that would be required, and this is how that works, right? No default implementation that can be broken. You have to edit yourself. And if you then automatically derive derive is actually kind of misnomer in a way, but still, if you auto-implement partial equality and equality and hash, for instance, then you will have a perfect implementation where nothing can go wrong, whereas in the Java version, you see that it's manually implemented here, and you return an actual hash code, so the algorithm used is not decoupled from the fields used to create the hash code. I find that quite amazing, cumbersome, in the Java world, and also very error prone because, well, can you tell that you have written a good hash code for your type? Whereas besides the fact that you let the compiler implement it, if you look at the code, then you will see that you get a hasher, and the hasher is able to take certain types like U8, U16, or byte strings, or a bunch of bytes, and will do the hash for you, so you don't ever have to be involved in writing a good hashing algorithm, which basically something most people cannot do and don't want to do in the first place. But Java kind of makes you do it because of the interface here. Yeah, I think the worst thing is that you auto inherit implementations that are not working for you. So item 9 is a phone number example, which I have here partially. And as you can see, we just have some shorts, which are 16-bit signed integers with an array code prefix and line number. It's all private final fields, so you can't really do anything with that structure. You do a range check, and based on that, you get an exception thrown. As usual, it's illegal argument exception, which basically means your program can crash, and you don't even see that it can do that. Well, it doesn't crash, but it does abort. And it's a general problem with Java that you have unchecked exceptions next to checked exceptions, and most people seem to use unchecked exceptions, which is, if this is a standard exception, and if this is what you're supposed to do, then this is how it is. But who says that these items passed in are not parsed by some user input which you don't trust? And then, the only way for you to check that user input is by catching these exceptions, which you never know of unless you have the code in front of you, which you just usually don't have. I think this is terrible. So if you wanted to implement something like this, then like a check creation of that thing, then we might want to do it like that. We have a new checked, maybe new new checked. Let's call it new checked. And this would, because we actually do some checking, and that because of that we have a result here that we return, which is either a phone number or it's some, let's call it some string that says why we can't do stuff, right? So in order to do the checking, we probably want to have a little function here that takes the input. Oh, by the way, what's the input? It's the area code U16 prefix U16 and the line number U16. And the check method, what does it get? It gets a min and a max, or the argument, a maximum value, and the name. Okay, so arc is U16, max is U16, and the name is just a string, and it shall return a result here that has a string, or unit, so we don't care about it, but it has a string that we shall then return when we use this. So in this check we say, well, if arc is less than 0, that's something you don't have to check because we have use sizes, right? And I would like to stick to that, to be honest. And if arc is larger than max, then we return an error that says is to, we can actually make this a bit nicer. Field is too big, must not exceed this value, like this. Okay, now we throw it in and say name is too big. Where do we put the value itself? Let's put it here. So arc must not exceed max, and that is that. Otherwise we return an OK, and we are good. So that's our check method here. It's internal, it's like a closure that is only that is scoped to our actual creator here, just so that it's, well, not cluttering up our actual interface, right? Which should be pub, by the way. Right now this is nothing you would want to use because, well, this is not even pub. If you wanted to stick to what they show us here, then we would make it private indeed, or keep it non-public. Well, and now it's really about time to make the test. Oh, by the way, what if you would return arc, like U16 here? Then we can use it more easily. So like that, right? We wanna return an OK phone number that is the following. Maybe I do it like this. So then we have to set the area code. No. The area code, which is a try check area code. Oh. Then the maximum shall be 999, and it's area code here. Voila, then the next one is prefix. Try check prefix with 999. Prefix, yeah, it's a bit repetitive here. And then line number is try check. Oops. Try check line number, and that's 999 maximum, and we are done. Good. So that's the code here. Looks funny, but does exactly the right thing. And compared to this, right, here it's kind of separated. Here first check, and then you make the assignment. You actually also cast it, right? If you wanted to, well, the thing is, I don't know why I would take different a different pod here. Why would I allow a 32-bit int if I actually am planning to break it down to U16? So I'm not sure who the client of such a function would want to be, but I think that's quite rusty. Or that's the rusty equivalent here. Interestingly, we kind of hide the checking functionality in here, so that we, I think, have a nicer interface. It's a bit less cluttered. So the equals implementation is something we would just get by saying we want partial equality and equality. Damn it. Like this, and now we are done. We have a perfect equals. Of course, this standard boilerplate for every equals that you will probably ever write in Java, which checks for object equality and which verifies that you don't try to, well, compare to something that is not a phone number, but this could fool you into basically allowing subtypes here, which, you know, could, well, it's really, this is what you get when you have a real inheritance and do instance off checks. But anyway, so that's kind of the standard boilerplate that you need, and then you just cast it and do the test accordingly. So again, the hashing is quite interesting because it really implements a certain hashing algorithm, you know, and for this you need a lot of knowledge to get this more or less right. And still, again, you kind of pair the hashing algorithm with your object implementation itself, which I think is a bad thing to do. So yeah, you can't improve the hashing algorithm later without changing all the different kind of redundant implementations, right? After all, this can be auto-generated, and this is exactly what Rust does for us, fortunately. So I think if we allow this here, if we put it in, then this test, if we run this type, first I think we want to build the current class and then we want to run it. Unfortunately, you have to build first. This kind of shows that it worked. Let's have a similar test in Rust. So use std collections hash map. So now we can set up the map, which is a hash map new. See the absence of any typing here because that's all inferred. So in the moment we do an insertion to our hash map, the types will be inferred for us. What's the thing? We want to have a phone number on the left side, phone number new checked, which is 7078. It doesn't really matter, does it? 8675309. And of course, you don't want to put the result in there, but the valid thing here, the valid instance that we generated, and this is going to be Jenny. And yeah, I think this returns an optional with the previous value in the moment we added that, so we don't have to check that this existed or not because it's an empty hash map that we started off with. And now we are supposed to print something, that I would prefer assertions here. It's probably, you know, I think the only reason he does it that way is that it's too cumbersome to get a unit test here. So you just add a main to have something that you can run and show, you know, but in fact in Rust you would just do it that way. And yeah, phone number, phone number, I can't type right now, sorry. Phone number hashing. So assert that, what do you want to assert actually? Yeah, we just want to get the same number out of there. So it's mget is sum would be enough. Oh no, wait. Then we can do an assert equal. Unwrap shall be Jenny, because that's the value that we are supposed to get when throwing in this key here. So that's kind of, you know, we are repetitive, we are redundant, but that's just mirroring this code. Interesting, you just put that thing onto the heap, right? To get the object. There's no such thing as stack unless you are dealing with primitive types. It's quite amazing. And sure, this is a garbage collected language, right? But I think even Go supports the notion of stack, and you can keep stuff on the stack if you simply don't use new. Yeah, so let's see if that actually works. So cargo test. I think we are also in item 9 here. Item 9, excuse me, cargo test. Let's see if that even compiles. Yeah, you wanted to have an assert equal here. Let's see. So it wanted a phone number reference and got the resource itself. So now this should be better. I hope this unwrap does the right thing. I think it does. And yeah, partial equality is not implemented for type string, really. That's a bit odd. What do we, oh, I think we have to deref it, right? We might get a doubly borrowed string here, because what we get is a reference to the type T, and T is a string slice, which is a borrow on an str. So we get a double borrowed. In order to make them compare, you have to deref it just once. I think that's what we see here. Yeah, that's what we saw. Cool. I think if you do the cargo test lib, we don't see all this extra garbage telling us that something is never used in the, I think, doc test part here. Nice. Of course, in the cargo configuration, you can disable this doc testing, so you don't have to bother with that. Yeah, doc test, another nice thing. I don't know if that exists in Java. I didn't get there yet. Might never, but at least not in the course of the book. But yeah, that is that. I totally prefer this code. I mean, look even at the verbosity of this, just due to the missing type inference. And yeah, it's just gorgeous. If you wouldn't have that, then you would have to do it like this, right? Then you would have to do phone number and str. So that's the same thing. It will work similarly well, but of course it looks quite ugly compared to the sleek implementation that we had before. Yeah, interesting. I think in Rust it's so much easier to write good code, working code, safe code, just by the way the language works. Honestly, it's quite amazing to see it if you compare that explicitly. Also, this constant mewing here is of course a nuisance because you just don't need that. And it of course costs you in the computer precious resources. So that is that. See you around. Thanks for watching.